All right, college algebra people. I put this review on Blackboard, so if you want to download it, whatever. And then I circled a few that I'm going to do. So here we go. I'm going to start with number 4. Now, because Blackboard, I don't know if I'm doing it correctly or not, but this equation on your test will look like, will look like this: 8x minus 8 equals, and it's going to say square root parentheses 4x. If I were you, I would have a piece of paper on, right next to me while I do all these work, so that I can change that so it looks like, the original problem. Because I can't make a square root sign in Blackboard. At least I can't. Maybe somebody else can. But this is how your test is going to look. So make sure that you know that square root is SQRT. One of the problems has fourth root, and I think I did fourth root like this. I don't even remember. So just be aware of that. I'm going to give you my cell phone if you need to call me during the quiz or test, because it's just going to be very confusing, I think. Anyway, maybe not. Maybe I'm over exaggerating. All right, anyway, so when you have a square root, the first thing you have to do is isolate it. This one is isolated, and now I'm going to square both sides. So x minus 8 squared equals the square root of 4x squared. The reason we do that is because squaring a square root undoes it, because they're inverses. So I just have 4x over here. Now again, be super careful when you square x minus 8. If you have to go off to the side and write it twice, then write it twice. So x squared minus 16x plus 64. All right, now I'm going to subtract 4x from both sides. I probably should have done this ahead of time because, x squared minus 20x plus 64. Oh, and I think 20 is going to be 64 is 16 times 4, I believe, right? Yep, so they're both going to be minus, so x minus 4, x minus 16 equals 0. So that means x is either equal to 16 or 4. And remember, you have to check. You can't just, let it go. You have to check, and you have to check in the original. All right? So the first thing that I notice is with the 4, when I do 4 minus 8, that's a negative number. That's a negative 4. So right away I'm going to throw away 4, because we're talking about principal square roots when we solve equations like this. So I'm going to throw the 4 away, and I'm going to check the 16. So 16 minus 8 is just 8. Does that equal the square root of 4 times 16? 4 times 16 is 64, and the square root of 64 is 8. So then I would keep x equals 16. Remember, this is multiple choice tomorrow, so it might have x equals 4, might have x equals 16, but make sure you just pick the one that's the correct answer, okay? So that's number 4. The other one I circled, well, let's jump over here to number 9, because number 9 is similar to number 4. All right, it's also a square root, and this one tomorrow, if there's something like this for you to do on your test, it's going to say square root 5x plus 1 equals x. And the parenthesis will stop where the square root sign is. Okay, so we're going to do the same thing, except we're going to have to isolate the square root. So now I have the square root of 5x plus 1 is equal to x minus 1. And then I'm going to square both sides, because that's how I get rid of square roots, is by squaring both sides. So I have 5x plus 1 equals, again, be careful squaring this, x squared minus 2x plus 1. And now, because it's a quadratic, we're going to make it equal to 0, minus 1, so minus 5x minus 1. So I get 0 is equal to x squared minus 3x. That's nice. That's easy to factor. That's x minus 3, because those 1's canceled out, which means that either x is 0 or x is 3. Now remember, I have to check, and I have to check in the original. I have to check in the original, not the one that after I subtract 1, but I have to go back to the original. So I'm looking at 0 in that, and so if I check over here, the square root of 0 plus 1, does that equal 0? Well, and that answer is no, it can't be equal to 0 because I'm adding to 1. So this would be not 0. So I'm going to throw away 0, and now I'm going to try 3. The square root of 3 times 5 is 15 plus 1. Does that equal 3? Right? Right. So 15 plus 1 is 16. Square root of 16 is 4. Is 4 plus 1 equal to 3? That answer is no. So I throw it away and I say no solution is my answer because neither one of those worked. And if I were to graph those two, I would probably see that they don't match up. Let me quick graph. I wasn't planning on doing this, but let me quick graph on Desmos if I can find it. There it is, Desmos. And if you want to check your answer with your graphing calculator, you can. You can't check it on Desmos because that's not allowed. But I can check it on my graph here. So the square root of 5x plus 1 plus 1, and the other one was x. So, is that right? 5x plus 1 plus x, 5x plus 1 plus 1 x. Why am I getting no solution? What did I do wrong, y'all? Oh, because I'm a dingbat. Look at this. Look at this, dingbat. How come nobody yelled at me while I was doing this? Here, this is not minus 3x. This is minus 7x. Where'd it go, Struckman? So 3, cross this out. Nice. I'm glad everybody caught that for me. So x equals 7. So I go back to this and see what happens. This one should work now. So I get 5 times 7 is 35, which means this is the square root of 36, which is 6. Does 6 plus 1 equal 7? And that answer is yes. So notice how I did that with my graphing. I put one side of the equation into one of them and then the other side into the other. And notice, where do they cross? They cross right here at x equals 7. So that's another way to do it, which is not showing me any math, but since I'm not checking any math, you could do it that way to find out. All right, and the last one that has a root, I think, that I circled. Yeah, the last one that has a root is this cube root. Okay, so if I did a cube root, remember I probably would have written cube root parentheses 2x minus 1. So keep that in mind tomorrow when you see that. So this is a cube root. So I have to both sides. So I'm going to do 3 cubed is equal to the cube root of 2x minus 1 cubed. So this is just 2x minus 1. This is 27 because 3 cubed is 27. And this one actually is pretty easy. Add 1, so 2x equals 28, so x equals 14. And then I can check that, but likely it's going to work because I don't have x's on both sides. It's only when I have x's on both sides that gets really kind of weird. But anyway, 2 times 14 is 28. 28 minus 1 is 27, and the cube root of 27 is indeed 3. Okay, so we have to check it, even, whatever. So those are the cube roots. Absolute value, let's do an absolute value equation. Remember, greater than is an or statement. Less than is an and statement. Okay, so this is going to be 2x plus 6 is greater than 16, or 2x plus 6 is going to be less than negative 16. Remember, we switched the inequality and the sign. Don't change the thing inside the absolute value, just the thing on the outside. So subtract 6. So I have 2x is greater than 10. So x is greater than 5. Or subtract 6. I get minus 22. So 2x is less than minus 22. So x is less than negative 11. So that means if I were to graph it, I would have had negative 11 here, open circle, everything to the left, and I would have had 5, open circle, everything to the right, and then in interval notation, that would have been negative infinity, comma, negative 11, bracket, parenthesis, or is the u, and then it would have been 5, comma, positive infinity. And that's pretty straightforward, of course. I have now gotten into this other problem. Let me get rid of that so it declutters a little bit. Remember, with absolute values, there's always two kind of answers. I think there was one more absolute value. Here's an equal equation. So the first thing we do is we isolate the absolute value. So plus 4 plus 4. So I have the absolute value of 3x plus 1 is equal to 3. If that would have been a negative 3, I would have said no solution, because absolute values are always positive. So now 3x plus 1 is equal to 3, or 3x plus 1 is equal to negative 3. Right? Subtract 1. So 3x is equal to 2. So x equals 2/3. Or subtract 1, 3x is equal to negative 4, so x is equal to negative 4/3. And when I do fractions, like these kind of fractions, it'll be sideways. It'll be the slashes. It will not be a vertical kind of fraction. It'll look like you're typing it, because when I did type some fractions like this mess over here, number 7. It looks like this. It's 6, and then I use the underline that, but then there's a big space, and the x is way down here. And then the equal sign is probably here, and then I had a 1 with underline, and the x minus 5 is way down here. Because when I hit the subtraction sign, when I hit the return sign, it gave a giant space between the two things. So this all, and I use the underline feature for this, x plus 4 up there on top. But this x, and this might even be a caret 2 minus 5x. Sometimes, depending on how I typed it, I couldn't get an exponent unless I just did the caret. So if you see a caret, the caret being this thing right there with the, it looks like a teepee. That's what it is. It's a square thing or a cube thing or whatever.